Hello and Namaskar. This is S.G. Kulkarni, retired associate professor from DKT's Textile and Engineering Institute, Ichalkaranji. We have seen up to the carding process about the short staple series discussion on cotton manufacturing, cotton yarn manufacturing. And we had seen also in the early units about the flowcharts. Now, today's discussion is specially focused on the draw frame, which comes both in carded yarn manufacturing, combed yarn manufacturing, as well as its role is also there in case of unconventional spinning processes. So let us start discussion on draw frame. Draw frame, just to begin with, to have some outline about draw frame, just a guiding principle. It contributes about less than 5% of the production cost. Of the total conversion cost of the yarn, right from bale cotton to the final yarn, it contributes only 5%. But here is the big but here. As it is, as I have just now stated, it is part of carded yarn manufacturing also. It bears number of passages in carded yarn manufacturing. It has some number of passages in combed yarn manufacturing. In combed yarns, especially in case of cotton, we use draw frame as a preparatory process as well as a post process. That is, after combing, again we use draw frame just to level. Level in the sense, what I mean here is, here that is mentioned, its influence on quality, and especially that quality, that is the evenness. And this particular point makes the draw frame a very critical, crucial department, crucial process in the entire spinning department. Further, the draw frame is not properly adjusted, there will be also effects on yarn strength and yarn elongation. These are the proven studies. What I have quoted, these statements, it naturally affects the evenness. If it is not set, what setting, etc., what criteria are there, we are going to see, but it definitely has impact on strength and elongation. Past studies reveal these things. Actually, as far as the references go, I think Dr. Cox, he first pointed out about fiber movement in drafting, if I recall his name correctly, in JTI 1948. And then again, Dr. P.R. Lord, he again published papers around 1970 in JTI, fiber movement in drafting. And of course, we have a very famous popular book, Principles of Roller Drafting by Foster. These are very, say, highlighting and very critical references we have for all these discussions. And of course, later on, some of the research papers, those are published in different studies on carded yarns and combed yarns and unconventional spinning processes, impact of draw frame, and with due course of time, as I have stated in case of blue room and also in case of carding, draw frame has taken a totally different shape, phase in today's situation. So let's move ahead. A defect arising from draw frame itself can exert an effect of significant proportion on overall process. The essence of this thing is, we have, say, three kinds of the fault generation: natural, random, and due to the mechanical processing. These are the three basic aspects. Now, if any defect arises here, can exert a significant proportion on the overall process in the downstream processing. The meaning here is downstream processing. In the sense, if you are going for carded manufacturing, obviously we have two passages, minimum two passages. One is breaker draw frame, another one is finisher draw frame. Breaker draw frame's role is different, finisher draw frame's role is different. Normally, in the industry, finisher draw frame is equipped with auto levelers, not the breaker one. And of course, keeping the process parameters, there are also some significant differences are there. Later on, we will discuss about that. High performance draw frames currently produce over 200 kilograms of sliver per hour at each delivery. Now, of course, this has gone up. Production rates definitely have gone up than this, what I have mentioned here. But production rate, apart from the production rates, there are significant changes because of which the production rates have been, the people are able to increase the production rate. That will be our main focus. Therefore, it should be noted that a very large quantities of poor quality sliver will be produced in a certain time before discovery of the defect. Means we are required to analyze and find out the defect at the earliest when not larger quantities of the slivers have been produced. So we are required to be very alert here. Means attentiveness and maintenance, and quality control, these three in tandem will play a very critical role in case of handling the draw frame. This is what is the meaning of this one. Two main reasons for considerable influence on the draw frame evenness. Firstly, the sequence of machines in the cotton spinning mill. Draw frame is definitive compensation point for eliminating errors. The meaning here is, if at all blow room has gone wrong, the card will correct it. Top size is the top size is larger, which is coming out of blow room. It can be rectified, corrected at carding department, carding machine. Top size will be reduced and fibers will be segregated, as I have mentioned in the carding process. And then here, if at all any clusters are there, these clusters, the cluster of fibers will be treated properly in case of draw frame. Inadequacies in the product leaving the draw frame not only pass into yarn, they are actually reinforced by drafting effects following the draw frame. The yarn is never better than draw frame sliver. Means, if at all any drawback remains here, which is uncorrected, means this is a kind of a turning point, one can say. In a general discussion, what we can conclude is, this is the turning point where we can have some rectification of, if at all any inadequacies are there, as far as the quality of the material is concerned, the sliver is concerned here on the draw frame, and in the succeeding stages. Now, in the succeeding stages, why we are stating this thing? Because at the speed frame, for example, or at the ring frame, if they are following after the draw frame in the carded yarn route, then there is no multiple end feed and single end delivery, which is only done in case of draw frame. Multiple ends are fed and one end is produced. Whereas in case of speed frame, we have one end fed, one end delivered. In case of ring frame, again, one end fed and one end delivered. Not only one end fed and one end delivered, but the size also goes on declining. There is reduction in the cross section of the produced product in the speed frame in case of the ring frame. Number of fibers they are reduced in the succeeding processes. So that's why this is a turning point that makes the draw frame very critical process which is to be monitored properly, set properly, etc. etc. So let's begin. Let's go ahead rather. Now differences already we have seen in case of the carded slivers and drawn slivers in the flowcharts. One more point here. Again, draw frame plays a very important role as far as post comb draw frame is concerned in case of the combed yarn manufacturing. It comes as I have stated just a few minutes before that it acts as a preparatory process. So combed yarns, we will have a draw frame, then a superlap or unilap machine, then comber, and then we will have a post comb draw frame. Now this is the leveling point because piecing wave is generated in the combed material, combed sliver. As we are going to go to the combing also after this particular discussion is over on draw frame, we will see there in detail. But a piecing wave is generated. We are inevitably we are piecing the material means overlapping the material to produce a continuous material from comber. So which is to be corrected, and that position that is done at the post comb draw frame. If it is a blended yarn manufacturing, again a pre-blending, blending and post-blending draw frame is there. If we are treating polyester and cotton, polyester and viscose, etc. So draw frame has a different kind of role when it comes to the yarn manufacturing. We are basically focusing here on short staples series on cotton. So let's discuss about this difference between carded and the drawn sliver. Fibers are oriented in different directions in card sliver. Fibers are oriented in the sliver axis direction. In case of the drawn sliver, means orientation of the fibers gets improved, aligned. Sliver contains hooks. Here hooks are straightened. Many fibers are projected out of the sliver. Very few fibers will be projecting out of the body of the sliver. Kind of a hairiness of the sliver we can say. That gets reduced when drawing is done. Draw frame does its job. Irregular weight per unit length. More regular weight per unit length due to doubling and auto leveling. As I have stated, auto leveler will be there in the post operation. A breaker draw frame will not have an auto leveler, but multiple end feeding will be there both in the breaker draw frame as well as in the finisher draw frame. Now objects of draw frame. Drawing and doubling of card slivers and thereby improve the uniformity and straighten the fibers. First straightening will come and then it will be followed by the uniformity. There is a difference in straight position of the fiber to the axis of the sliver and uniformity. Uniformity straight term denotes relative position of the fibers and uniformity denotes about the bunch of fibers taken together. So this basic difference is there. So both are getting improved. Orientation is improved and mass distribution gets improved. So that is basic object of the draw frame. How mass gets improved, regularity is obtained, acquired by the material, we are going to see in the succeeding discussions. And again I will tell some more points about this. Let's finish up this slide and then we'll go for that. Drafting of card slivers and thereby improvement of parallelization of the fibers. Now, straightening is pertaining to a single fiber and parallelization is relatively. There is a relativity. One fiber is straight and other fiber is also following the same alignment. Other fibers, many fibers we can say. So that becomes parallelization of fibers. So we are required to have some mechanism here which will straighten the fibers first, make them parallel, and then have a uniformity of mass. Try to take into account these things. So these are multiple things which are attained when we are utilizing the draw frame. Of course, in one single step, this can't be obtained. That's why we have at least one breaker draw frame after carding and one finisher draw frame, and then followed by that speed and ring frame in the carded yarn route. And if it is a combed yarn route, in case of cotton carding, then we have a preparatory draw frame, so pre-combed draw frame you can say, then a lap former, then the comber, and then the post-comb draw frame, and then it will go to the speed frame and ring frame. If different routes are there, roll of draw frame will be, as I have stated earlier also, that will be different one. Formation of slivers. Now, as I have stated just a few minutes back, multiple ends are fed in case of draw frame. Usually there were 6 in the conventional orthodox draw frame, and here we have in today's situation we feed normally 8 ends and 1 end is taken. 8 slivers will be fed at the back side, creel, and then 1 sliver will be taken ahead. Now, certain conditions are required to be met if we really want to have a draw frame. Preconditions, what I have discussed in case of blow room, what I have discussed in case of carding. Now, what are the preconditions for drafting to take place? You must have at least 2 pairs of rollers. 2 pairs of rollers. One bottom roller, one top roller, another bottom roller, another top roller. This comes actually from, of course, Casablanca's principle or hand stapling. This comes, we can say, hand stapling, where forefinger and thumb was used of one hand and another forefinger and thumb was used of the other hand, and then hand with the hand drafting was done, means it was pulled, the material was pulled by gripping at one end. The fibers were gripped at one end and they were pulled from the other end, and repetitively this process was repeated multiple times so that the fibers slide past one another, they have a friction between them, among them, and then they become straight, and at the same time they become parallel, and at the same time, as per the manual judgment, we can reduce the mass also. So 2 grips are needed, minimum 2 grips are needed. For grip to be formed, we must have top roller loaded. Both the rollers must be loaded, top rollers must be loaded, and then they must be set apart a certain distance which is in relation with the fiber length, the staple length of the fiber, or you can say upper quartile length of the fiber, upper half mean length, whatever term you use in the today's situation. So depending upon that, we are required to set these 2 pairs apart, load them, the top rollers, and run them at certain relative speeds. If this is the back roller pair and this is the front roller pair, then as compared to the back roller pair, surface speed of the front roller pair nip, that has to be a multiple times, and that is what we are calling terming as draft in the drafting system. This is called as the draft. The rate at which the material is pulled forward is draft, and that creates one. That's what I have mentioned. JTI paper 1948, fiber movement in drafting, and P. Lord's paper 1970, and principles of roller drafting by Foster. Everywhere you will find the same basic fundamentals, that we must follow these conditions, then and then only mechanically the drafting will be done. Hand stapling, of course, it is a slow process. Manual say intervention is involved in that, and man's judgment will decide this thing, that whether the straightening has occurred or not, etc., etc. So many constraints are there on that. But when we do mechanically, we are setting certain things, and these are the three preconditions. If one has to get the basic process correct, we are required to target these things. Either the grip has to be correct, means the grip has to be correct. For grip has to be correct, the roller loading has to be correct, the setting between the rollers has to be correct, which is slightly greater than the staple length of the material. Staple length plus 1/8 inch in the front zone, staple length plus 2/8 inch in the back zone, etc., etc. A back zone setting is slightly wider as compared to the front zone. That gives a brake draft, and the front zone gives the main draft. If at all we have 3/3 system, we are going to see when we go for the discussion on the same. But there have to be certain conditions which are required to be fulfilled. Then and then mechanically the drafting will do what objects we are assigning to that particular system. So it must follow these preconditions, then it will work satisfactorily. Of course, there will be some external matters which will hamper these things, the material, the previous processes, and the environment, and the work practices. They will hamper this thing, but this, if they are treated as constant, the mechanical system will do its job properly. So let's move ahead. Now, this is the passage of material through the draw frame. Here we can see this is the creel of the machine where multiple cans are placed. Now this is a conventional process. So here we have indicated 6 cans. You can clearly see. There will be a difference. Here we have, means lot of differences of course will be there. We will have 8 cans, and then spoon lever stop motion was there in the conventional process. So this was a mechanical stop motion. Lately we will discuss this thing at the end, I think, of this presentation, how the stop motions, mechanical stop motions and other motions, at that time we will discuss about that. But if any sliver breaks of this, the machine should stop, otherwise the machine will run with the less number of slivers. That is why the stop motion was created. And we can see here actually this is a 4/4 system. 4/4 system. Now this 4/4 system that will draft. Now there later on people found out that there has to be some optimization of the number of zones. This will create one roller pair, and this next roller pair, this will create one zone. So this is the brake zone, this is the middle zone, and this is the front or main zone. So this is back zone, middle zone, and front zone, we can say. But this is brake zone, where all these coiled the slivers, they will be opened up, and wider setting will be kept here. This is a neutral zone. There should not be any roller slip here. otherwise it will lead to some irregularities in the material. And this is the main zone. The front zone is the main zone where actual draft is given, because 6 slivers we are feeding, we are required to produce the same hang, nearly the same hang. Suppose we have a 30s yarn that is produced from these slivers. Later on we are keeping the sliver hang here 0.12 in the indirect system. Effectively, this sliver will also have, it should have 0.12 hang in the indirect system. So 6 ends fed, one end is produced, hang should remain the same. And this is the coiling mechanism. So this is creel, the this entire thing is the creel. This is the drafting zone or main heart of this machine, and this is the coiling zone. Condensation, here the material will be condensed and then it will be deposited in the can, which is rotating, which was rotated in the conventional days. So this is outline of passage of this particular machine. In today's situation, as I have mentioned earlier also, this is in this picture, you will notice this is a very sophisticated autoleveler draw frame. This picture might not be very clear, but this is a photograph of a very high speed autoleveler draw frame, where we have a sophisticated guiding system for the slivers into the drafting zone. Then sliver monitoring also there. What quality we are producing, that will be monitored on modern machines. And then we have the high speed coiler plate. So there are changes in this particular different zones. There are modifications. We are going to see in due course of time these things. A breaker draw frame normally might have a double delivery system, or it could be a single delivery system. So here in this photograph you can see this is a breaker draw frame with auto doffing system. So cans will be doffed and it has two heads, and at the back there is the creel of this machine. This machine will operate, it is required to be attended by the operator, a twin delivery, but doffing will be done by the mechanical doffing system. Now, the tasks of draw frame: equalizing. As I have discussed earlier, one of the main tasks of the draw frame is improving the evenness of the material. Short, medium, and long term we already discussed in the carding process. Up to a certain level, we treat it as short term variation, medium term variation, and long term variation. So card slivers which are fed to the draw frame have a degree of unevenness, though there is segregation of the material that has taken place, but there is missing, the evenness is missing of the material, so we are required to make it even. But before making it even, we are required to straighten it and parallelize it. So this objective is parallelization of the material. Before that we have to straighten it. When you grip the material and pull the other end, a relative speed acquired by the fiber, front tip of the fiber, a single fiber is traversing at the front nip speed and back end is traversing at back nip speed. So that speed difference suddenly creates the straightening, and that straightening creates in the multiple fibers a parallelization, a parallelized state, a parallel state rather. So this is how the parallelization is done in case of the draw frames. Parallelizing the mass of fibers, volume of the strand, and degree of order, parallel disposition of the material. Simultaneously it will attain all these things, the parallelized material. Now blending. Of course, blending here in case of this cotton short staple series also is true, And in case of other materials which are deliberately we are going for blending, there also it is true. Blending means the random distribution, one can say, very in the overall manner, a very in a nutshell, what we can say is blending is distributing the material randomly, just like we have seen in case of the multi-mixers in the blue room. This disposition will create a distribution of materials at random, means repetitiveness will not be there of the same kind of material at same place. So that is blending. That task is also done by the draw frame, and this is basically, this has become possible because of the fiber movement in the drafting. So it goes to the basic. Now again, this is discussion on the other compositions. When we have 6733, of course we take a different routes for blended yarn manufacturing also. Either we blend at blow room itself or we blend at draw frame. So there are various kinds of things which are pertaining to the blended yarn manufacturing. Now dust removal, this is to some extent it is done on the modern machines, because just like we have seen in case of carding and blow room also, the provision of suction at certain places, it attracts. Now of course here we can say presence of micro dust will be there, and that openness whatever has happened of the fibers, that will subject to, that will make these fibers or this micro dust rather to be said ejected from the mass. So this is a slightly complex phenomenon here, but we are treating this as that it can tackle to some extent, modern draw frames can tackle to some extent the micro dust removal. So that's why this point has been taken here. We are required to remember this thing, that parallelizing, blending, of course straightening, equalizing the mass, and to some extent removal of the micro dust. To some extent we can say removal of the nets also. That's what is the objects, that's what the function and objects, these are the tasks which are assigned to the draw frame, modern draw frame we can say. Now just now I have discussed about this one, that we need to have certain preconditions, and this diagram illustrates these preconditions we can say. This is a roller pair, one roller pair. In the conventional days, this was also metallic serrated, this was also metallic serrated, this was mechanically loaded, this was serrated, this was also metallic and serrated, and then we used to do drafting of the fibers in these roller pairs. They were set apart a proper distance, a known distance. They were turned, of course, very important thing is bottom rollers are normally given a positive drive from back to the front. If we treat this as a back of the machine and this is front of the machine, then this always they will rotate from back to front. This direction of rotation will be the same in case of these rollers, and these top rollers will rotate because of frictional contact, and that's why on modern machines we have slowly and steadily gone for the top synthetic rubber covering. Synthetic rubber covering, that is a very important thing. Not only it gives a proper grip, it gets distributive load when the question comes of gripping of the fibers, and then releasing also. I repeat my statements what I have used in case of carding, retention and release. This is the principle behind every aspect after carding. Even in case of blow room also we can say that retention and release. If only the feed material, I mean the feeding rulers, if they go on gripping simply and beater will go on beating the material, then totally chaos will happen. The material will get damaged. So retention and release, this we can say, as far as my statements are concerned, these are my own terminologies, what I have derived from my teaching experience. Retention and release, these are the key aspects. This roller pair must retain the material as long as this has not caught. As soon as this roller pair has caught this material, this should have released the material. This should not retain. If it retains, the material is gripped between these two pairs at the same time and the material will break. So, retention and release, this is the key point at every aspect, every department, every process in the spinning section. This is very important. Now, the roller set. Now we'll go to this roller settings. Nip to nip distance of the rollers is called as roller setting. Roller setting is done as per the staple length of the fiber, as already I have stated. Front zone effective length plus 3 mm. I had discussed in terms of inches slightly some time back. Middle zone effective length plus 6 mm and back zone effective length plus 9 mm. A wider distance as we go from front to the back. Back zone, break zone's function is different. To open the material properly, present the material, that material is presentable to the succeeding zones. Of course, in today's situation, only two zones have remained, or zones have changed rather. We are going to see that as per the roller assembly typical evolutions, these things have changed, but this is a guiding principle, a guideline you can say. This setting is required to be kept like this because to avoid fiber damage and to open up the material properly and present it to the succeeding zones in a proper fashion at a given particular speed, so that whatever the objectives we have assigned to the draw frame, they can be fulfilled, we can obtain them properly. Now, model drafting system, of course, there is a difference in case of this MDS, what I have treated this particular thing. 3 by 4, 4 over 5, 3 by 5, or 4 over 5. Normally, 3 over 3, I term it as symmetric drafting system. If it is a 3 over 4, top 3 rollers are there and bottom 4 rollers are there, this is asymmetric drafting system, 3 over 4. And if it is 5 over 4, then it is inverse asymmetric. 5 top rollers are there and only 4 bottom rollers are there. This is inverse asymmetric. So these systems, they have these various things. Different manufacturers, they have their own considerations. And draft normally, suppose 6 ends we are feeding and same hank, as I have stated earlier also, same hank we have to produce. We should not deviate from the hank as far as possible. We are required to keep slightly less draft as to the number of doublings. Number of doublings are 6. Normally we will keep a draft of 5.9. And break zone draft, normally we will keep 1.2 to 1.5 at the most. And accordingly, in the modern evolutions also, they say that middle zone draft, if at all we have 3 zones, middle zone draft should be neutral 1, and break zone 1.2 to 1.5, and rest is there in the front zone. So accordingly, we are required to manage the drafts also with given kind of drafting system. Now, operating principle we have seen in the passage of the earlier machine also. we are having multiple end feedings, here. This is the These are the cans which are placed. Then feed rollers are there. These are sometimes they are called as lifting rollers, which lift positively the material from the cans. Otherwise, what will happen is, in today's situation, now we have the sensors here, so that if any break occurs, the stop motion is actuated and machine will stop, so that less number of doublings, that machine should not run. And at the three position here, we have the drafting system, and at the four we are having the coiling system, the delivery rollers here, and the coiling system. And 7 is the can. So, right from 1 to 7, our material will pass like this in case of the operation of the draw frame. Now, feed roller pair carries out the lifting as I have stated. Now we will go to the, in order to avoid disintegration of the web, what we will do, avoid with the high operating speeds. At high operating speeds currently in use, we are required to do stop the machine if at all any end breaks. So normally when we are feeding, we are required to take care that the stop motion is very properly working there. Now here we are discussing about how the passage is there. At the number 5, calendar rulers, here calendaring mechanism, we have grooves here for the calendar ruler. And normally what auto leveling system we use, normally it is situated here in the groove of the calendar rollers, what we are going to see slightly later on. Now we have creel as I have stated earlier also, so we'll slightly go through this first. The first draft is avoided in the creel. Machine stops when occurrence of break. Sliver breaks can't dealt with easily, so comfortably and safely we are required to take care about this one. Otherwise, machine will run without the proper number of doublings. Now the creel here feeding takes place. We are required to take utmost care. The high rotation speed of the rollers of the creel, their maintenance, etc., should be given a due attention, and the stop motions which are working in case of this one. Now the drafting system is heart of draw frame, as I have already also have mentioned. Now we have various kinds of arrangements here. A simple uncomplicated construction, stable design, running of the rollers, centricity, the very concentric movement of the rollers has to be there, of the bottom rollers as well as of the top rollers. Otherwise they lead towards generation of what is called as a drafting wave. A drafting wave will be otherwise generated, which is required to be studied on the sliver which is produced on the draw frame. And on the regularity testing machine, we can get the curves of that. So certain variation curves can be obtained if at all any drafting wave is there. So we are required to keep a very close attention at this particular place. The mode of operation giving high quality product, high running speeds. This is the typicality of the draw frame. The roller speed is also high, and it is also supposed to deliver the quality material. Now, high degree of flexibility. This is very key point as far as the draw frame is concerned. Flexibility in the sense its suitability for various fiber lengths, sliver hangs, etc. Means it should be getting adopted. Settings can be done very fast, so that the draw frame adapts itself to the different situations, different materials. Optimal control over the movement of the fibers during the drafting operation. high precision of both operation and adjustment, rapid and simple adjustability of the roller spacing and draft levels, ease of maintenance and cleaning, etc. Now, operating devices influence of the draft. What the draft given by the draw frame depends. Mass of fiber, the cross section of the fiber which has come from carding, of course, degree of order of the fibers. Now this differs. We are treating if it is at the breaker draw frame stage, or it is we are considering at the finisher draw frame stage. Relatively, we are required to have considerations like this one. Degree of order of the fibers, shape of the cross section of the fiber strand, compactness of the fiber strand, adhesion between the fibers. This adhesion itself is the success behind the operation of the draw frame. The crimp in the fibers, of course, in case of cotton also we know from our basic study the fiber properties we can know. In case of cotton also convolutions are there. In case of man-made fibers, synthetic fibers, the crimp is there. The fiber length and its variation, this plays a very critical role here. What is most disturbing point as far as draw frame is concerned? The fiber length doesn't matter here. The fiber length uniformity matters in case of the draw frame. Twist in the fiber strand, the compression of the strand, evenness of distribution of length of the fibers. What previous history we have gone, according to that draw frame, we will change settings to a certain extent. We can create or say more distance or reduce the distance. We can increase the top roller loading. Loading also, the load distribution also is a typical one. For back roller, if two zones are there, back roller, backwardmost roller, that will be loaded mediocre. Then middle roller will be loaded low, and front roller will be loaded at the most, at the top. This is how the load distribution is there. Here highest, then mediocre and medium. Here less and here medium, we can say. So that way, though we play with the draw frame, say variables, we can say, various things we can adjust mechanically, we can play with them, but draw frame has to adopt itself. Now, it cannot sense what kind of a material is coming at a particular instance. If it is a cut sliver that is fed to the breaker draw frame, it cannot sense that. Auto leveler will mechanically act. Again, very important point. Auto leveler is not a magic. It will act upon the mass of material that is varying. So it will treat according to that. If it is a open loop auto leveler, we have seen in case of carding also, very brief introduction. Here also we will have a brief introduction, because all the draw frame, modern draw frame auto levelers are normally open loop auto levelers. So it will treat, somewhere it will sense that mass of material has varied, changed, and it will take a corrective action at a certain place. This is going to create some ambiguity. Its response is not very, that way we can say, very sensitive, instantaneous, we can say. So we are required to take care, a great care is required to be taken here as far as operating this device is concerned. Now, influence of on the draft, diameter of the roller, hardness of the top roller caught, pressure applied on the top roller, exerted by the top roller surface, characteristics of the top roller fluting in the conventional days. Now there are no flutes on the top roller in today's situation. Bottom roller flutes, their distribution, whether the flutes are axial or diagonal or herringbone type, etc. Various kinds of flutes are there as far as the bottom rollers are concerned. The depth of the bottom roller flute, the distribution number of flutes per given curve on that bottom roller, etc. This is a very important point. Type and form of the fiber guiding device such as pressure rod, pin bars, aprons, condensers, etc. Aprons and condenser, they are going to come slightly later. Clamping distances, roller settings, that is level of draft, distribution of the draft in various drafting zones. There are many points which are required to be considered when we are dealing with the draw frame. As I have mentioned, bottom rollers, to be very specific, they have axial flutes, they have knurled flutes, they have herringbone flutes, etc. etc. Various spiral flutes, etc. Means spot knurling means that is done at the spots are created. Why this change has come? Because we want to have a very aggressive in the sense very affirmative grip on the fibers. That's why there are changes. All bottom rollers are metallic rollers. They are knurled, various kinds of things are there as far as bottom rollers are concerned. The flutes can change, we can measure the flutes, how much projection they have, that can be changed, etc. etc. Main purpose is, and that is to suit with the top roller apron or the cot, we can say. Normally their dimension plays an important role, because how much distance we can keep between the rollers, that is one point, and at that distance what we can keep, whether it can successfully deliver the material from it to the next roller pair. That plays a vital role. So how much close we can have the setting, that can be decided. That's why the diameter of the bottom rollers and top rollers also, they play a vital role. Of course, that is governed by what kind of drafting system, symmetric drafting system, asymmetric, inverse asymmetric drafting system, what we have adopted, it will be governed by that. Now, top rollers, as I have mentioned earlier, many times top rollers are not driven positively. So this cross section we can see here, different kinds of bearings are used, different constructions are there of them. I will not possibly go in much details of that. Just we will study the outline of this. The cross section, here we have the actual roller, then this is the extended section of that. Here the housing of the top roller is there, where the bearings, etc. will be provided, and such on the both sides the such kind of arrangements were there. If at all we have a dual delivery drafting system, we'll have two kind of things here. If it is a single delivery, then our housing will be on both the sides. The soft cords are surrounding the hard bottom. Basic shell is there, that is of the material, any steel material, any metal we can say, and around that we mount the cot, so the soft surface is generated. That is another point related to the top rollers. So synthetic rubber is normally used. Top roller pressure, either you have a spring weighting, which is supposed to be very successful in today's situation. People have tried, experimented with pneumatic weighting, magnetic weighting, hydraulic weighting, etc. Hydraulic is very rarely used, and in the conventional days, the dead weights were used to load the top rollers. But what is successful is the spring loading in today's situation. Exactly, we can adopt a precise load with the tightening and loosening of the spring. So the top arm is used normally. The top rollers are housed in the top arm. We have discussed about the various kinds of drafts and distribution of the draft in the various zones. It is dependent on the zone what we are, what zone, how many zones we have. So normally break draft will be kept 1 point up to 1.5, and main draft will be in accordance with that way the main draft will be kept there. Now here we can see the 3 over 4 system. 3 over 4 system. The weights also have been mentioned here. Here we can see the, say, feed material is coming from here. The feed material will come over here, and various, say, what we can see here is a pressure bar. This is very important. A pressure bar we can see, and then in the final delivery we can see a condenser is used. A condenser is used, and then the condensing, coiling rollers will be there. In the main zone here, what we can see is a pressure bar, and this roller is supported on the two bottom rollers. So guiding of fibers will be proper, and plus any deflection, the deflecting fibers are there going out of path of this guidance, then this pressure bar, this is a very important thing that will deflect the material in the main zone, and proper draft can be adopted. So we have a very heavy loading here, brake zone, and then neutral zone we can say, and the main zone, and then the calendering or condensing zone where we can condense the material. Calender rollers will be used, and then that will go in the coiling system. So this is one kind of a mechanism. 3 over 4, 3 top rollers are there. So asymmetric drafting system has been used. In modern machines, a different kind of system and different angle is used actually. So 3 over 4 system, again the various kinds of sizes of the rollers, various kinds of rolls, loads which are applied on the top rollers, that is depicted here. Now 3 over 3 system we have. This is very conventional system where Platt's globe drawing it was called as, and where first they introduced Platt's globe drawing, they introduced the pressure bar. Pressure bar is a simple stationary element, half rounded element which deflects the material. That very successfully it can deflate the material in the main zone. Now this is discussion on the various kinds of mechanisms they have adopted. Now here we can see a modern system one can see. Here this is the back zone or back roller pair. This is the middle zone. You can see the deflection of this roller towards the front roller, and plus the deflecting guiding element is there, guiding element. And we have two rollers now. At the delivery side, we have two rollers. So this is 4 over 3. Now normally in modern machines, this kind of a system is used. This is say deflecting the material towards this. This is deflecting the material towards the main, and then a very assertive, in an assertive manner, the material will be guided down. This is very important development that has taken place on modern machines. Now there are changes also. We have a 5 over 4 system also, where you can see 1, 2 in conjunction they will act. a big roller here. 5 over 4 means 5 top rollers are there and 4 bottom rollers are there. 4 bottom rollers. These are the 4 bottom rollers and these are the 5 top rollers. Actually, they say that one should not go for more zones. Optimization of zones have come. So we are limiting our zones to a, say, slightly one can say maximum to 2 zones. But this kind of a system can create a kind of a one can say a 2 zones, because though the number of rollers have increased, effective zones have remained nearly the same, and roller dimensions have changed. The deflecting element is also present, and plus in addition to that, suction has also come. So that's what we are going to see. Now here the role of the suction, we can have analogy with the carding machine or blowroom machine even, where the trash is extracted. There itself we can eliminate that or dislodge that. Here this is not the question of trash, but the air current stability. Dust removal, micro dust removal is one objective, though it is true. But what suction we can see here, say from bottom also, when the material is progressing, going towards, now here this is back side and this is front side where it is going to the coiling. A kind of a stability is created, one can imagine here. When the material is treated, there also suction is applied from bottom, means because of rotation of the rollers, the fibers should not deviate from their place, they should move ahead. We are not restricting here, I don't mean here that fiber forward movement is restricted, but kind of a stability is created here. That stability will make the treatment of the draw frame very easy, and fiber movement will be enhanced, facilitated properly. And then the suction which acts from the top here, that will take the micro dust and whatever the things are there, maybe some naps are also there, which are just thrusted up, which are coming to the surface, that can be dislodged from here, and this will create a stability, a stable environment here. This will create a stable environment here, and therefore parallelization, fiber forward movement, straightening of the fibers and mass distribution, that will be helped in case of this. This has come on the modern machines. So this is a very important part of the modern draw frame functionality. This is very important. One has to remember this. Now this depicts about various kinds of what kind of things are acted upon. So the stability creation will be very important in case of this. Outside departments, air turbulence or air disturbance should not indulge into the operation, should not interfere into the operation of draw frame. That's why this particular very great evolution that has come, which has facilitated, and this has also helped in not only the enhanced quality of the material, but at the same time it has made the speed or delivery speed to be increased to a disproportionate margin, one can say. 100 and 1015 1500 2000 meters per minute, we can say estimated, we can run the draw frame, which is a very high speed, one can say, very high speed. Now next operation is of course condensation, and condensers or trumpets are used. Calendar rulers which are pressured, which will apply the pressure on the material, and the trumpet will guide the material properly. Funnel, that funnel kind of a thing. And here this funnel, which is just prior to the calendar rollers, here we are installing, I have already stated, the sensor for the auto levelers. So the field weight can be increased by 20%. Grooved or stepped rollers can be used simultaneously for measuring the auto leveling system. That's what is mentioned here. Simultaneously, what opened material is there, because of the drafting, it is required to be converged and properly condensed into a particular form, and at the same time we can take advantage of measurement. Now coiling, of course, earlier also in case of carding I have mentioned, the cans were rotated in the conventional days. In case of today's situation, either over-centric or under-centric coiling will be there. Normally over-centric, over-centered coiling will be there. This decides about how efficiently coiling is important from the point of view of, because this material is to be withdrawn, taken out in the succeeding stage. That's what we are required to remember. Not only we are required to supposed to accommodate more and more material here, but at the same time that condensed material here in the can also should be successfully withdrawn in the succeeding next step. That is also very important. So that way the coiling becomes very very important. And in modern drop frames also, whether twin delivery drop frames or single delivery drop frames, automatic doffing type drop frames, the can size has also gone up. Much of the material, very high amount of material, 20 to 25 kilos material you can accommodate in these cans. Very larger dimension cans are there with cascading wheels and all that, so that you can transport the material from one place to the other easily, and there is no damage to the material. Very efficient transport also is expected in this. So material handling is also taken care, has to be taken care at this stage. There were mechanical stop motions, back stop motion, front stop motion, and full can stop motion. These were electrically operated in the conventional machines. So we'll skip the mechanical stop motions. Now no longer they have been used here. Control of sliver hang, CB of course 1.5 to 4.5. Now in today's situation where Worcester standards are applied, Worcester 2.5%, etc., where CB has been considerably reduced, even less than 1. CB of this sliver should be less than 1, approximately 1 we can say. So that way changes have come. There are various kinds of drafts: actual draft, resultant draft, mechanical draft. Now mechanical draft is nothing but Hancock delivery divided by Hancock fed, or the weight per yard fed divided by weight per yard delivered, or surface speed of delivery divided by surface speed of feed. In these various things, the drafts are being measured. They have been measured actually, and there is a difference between the actual draft and mechanical draft. So actual draft is mechanical draft into 100 divided by 100 minus waste percent. Normally draw frame waste, at every draw frame we expect waste to be 0.25%. And draft constant mechanically, if you want to set, of course this was done on the conventional machines, where a draft pinion was there, draft change pinion, which was responsible for change of draft from front roller to the very last roller. It was not considering the brake draft. So that change pinion, if we change, draft constants were calculated and they were set. So actual draft and mechanical draft, they are differing. Now drafting wave. This is a very deep subject, one can say. The variation that comes periodically. That is the drafting wave. This should not be misunderstood with the thick thin places. Worcester thick thin places is different part, which is measured on 8 millimeters and expressed as plus 50%, minus 50%, etc. In case of cotton ring spun yarn, and nep, which is expressed on measured on 3 millimeters, I mean measured on 8 millimeters and expressed on 3 to 5 millimeters, and cross section increased by 200%, etc. 180% and 200% in case of rotaspun yarns. So there is a wave, periodic variation in the material, and that only comes due to the faulty settings on the drafting. So that basically is effect of the drafting system itself. Now auto levelers are mentioned already. I have discussed about them in case of carding. The auto levelers are the sensors are placed at the very back roller, as you can see visualize in this in case of this diagram. Measurement will be done here, and the correction will be done. Normally open loops are used. So incoming material, you will measure the variation, if at all any presence of that, and the processing will be, regularization will be done at the delivery place. So measuring point, fiber flow, control loop, corrective action is taken at the last. Means draft is changed. What is changed? That is the main draft. And it is expected that the correction that is applied will level the material. So this is the leveling, auto leveling. Now, of course, closed loop is not normally used in case of draw frame, which is used in case of carding. Already I have discussed there, and not much time I can spend on drafting wave and the closed loop and open loop auto levelers here, because that is not part of the basic discussion here. So we'll slightly go ahead. Now parameters of modern draft frame are 1000 meters per minute I have mentioned here, but it has gone up, even it has gone beyond that. Improved drafting system, 4/3 with pressure bar, which is the standard one, as I have shown in the earlier diagrams, where inclined kind of a drafting system is used. Roller pressure, pneumatic, of course, again they have switched to the spring loading, which gives the very precision as far as the loading is concerned, and there is, in the long run, there are no faults which are associated with this system. So normally spring loading is preferred. Of course, the doffing, the automatic doffing is used. Rectangular cans, which are used in case of the modern system, and automatic brake draft setting as per the sense material, incoming variability in the material. Correction is done in the speed of the brake zone also. So that way, rectangular can, just one point, the content can be increased. Rather than having a circular can, you can have a rectangular can, which can be possibly accommodated properly also, because there is a very popular concept in the industry, block creeling. Block creeling means all cans placed, the material placed in the backside of any machine like draw frame or in speed frame, etc. The all material should have same content, nearly same content. It should exhaust at the same time, so that all creel cans can be removed at the same time from draw frame also and from speed frame also, and the replacement of the material will stop the machine at the same time, and it can be started at the same time. So with that consideration, rectangular cans have been used, and automatic brake draft setting, as I have stated, that it will take care for the regularization of the brake zone. material. No clean oil, this deposition of the spin finish, that is in case of the man-made fibers. So some oil is used for the rollers so that they release the material. Basically, as I have mentioned earlier also, retention and release plays a very vital role. Now, the pneumatic pressure head, we have the camera to monitor that. Use the camera to monitor, and what happens because of that one is servo draft. That will sense, that camera will sense, just like the camera was used. This is specially in the case of the retars, especially in case of the retar. So what it has made is, not only it measures the tension, but the sliver quality is also monitored through that camera, and in accordance with that measured variation, we can regularize the properly the speeds of the rollers. So this is very latest that concept that has come. Other things, they have nearly remained the same. You can see here the 4/3 system they have used. This is the front roller, which is say accompanied by two top rollers here. Suctions will be there also, as I have mentioned, obviously. And then the condensation zone, in that place they have positioned this camera. So that has made the improvement in the quality. So servo draft, which is the draft which can be regularized with the presence of variability in the material. So that is very key change that has come in the modern systems. So this describes about the how it has exactly been done in case of. This completes this session on the draw frame. So I hope you must have gone correctly through this, and I hope if any basic doubts were there in your mind, those who are refreshing their draw frame or those who are studying the draw frame, some thoughts must have generated in their mind in association with the draw frame. So I stop here discussion on draw frame, and sooner we'll meet on the discussion on the comber and its preparatory. So we'll meet in the next session. Take care and goodbye from myself here. So I stop here. Thanks for watching.